This is my first time in Czechia, and I'm very excited to be here. And this is a very punk presentation on a personal project. So the title is quite honest. I reversed an Android application to try to hack transaction handled by an NFC tag. So let's start. Okay, you need to know that when I am not in my room to try to hack stuff like everyone, I like to go to live events, in particular musical events, festival. And it's very common that you can spend 2 or 3 days, an hour per day in a festival. And this means that probably you move from a stage to another to follow your favorite artist, but you need to drink and eat. And often you need to, I will say always, you need to buy food and drink inside the festival. Now there are different ways to buy the food and drinks in 2026. My favorite one is using just a credit card, because you just need to tap and you can have your food or item or whatever. But these kind of events are not designed in this way. They try to add friction and hidden cost for everything. So a very common approach is using token. Why token? Token because they try to hack your mind, your brain. A token often doesn't cost €1 or 1 unit. A token costs €2. In this way, you forgot the real pricing of item, because you see the pricing of item in the festival are expressed, are written in token, not in euros. And now, it's very common to find, application that manage tokens. So not physical token, but application where you can buy the token with real money and use this fake money to buy items in the festival. Why the application? Well, the main reason probably is that they can had to reduce the line to the different stands, food stands and drink stands. And also because in this way they can collect data about the user that enjoyed the festival. So in this case, it was quite basic. I had an NFC tag at the festival bracelet, and there was an application. I have an Android phone, and I use the mobile application to buy the token, the credits, and then the credits are stored in my mobile phone, or at least I can read on the mobile application the number of tokens that I bought, and I tap my phone on my NFC bracelet, I can transfer, so I can write data, the number of credit, on my NFC bracelet. Then I just go to my beer stand, because the only thing that I wanted to a festival is a beer, and I try to pay the vendor using my bracelet. The stand operator has the same app or a similar app, just maybe with a different backend. They tap the app on my bracelet. If I have enough credit, I can get my beer. Then, in this specific scenario at least, the vendor application send data to a cloud infrastructure. And why I know this? Because after that I paid my beer, even if I haven't tapped my NFC tag on my mobile phone, I have seen the credits, that my credit was synced, so updated on my mobile phone. So this is the user experience, the workflow. You have a tag, an NFC tag, you have a mobile app, and the operator has another app to check your credit. If you have enough credit, you buy the item. Otherwise, you need to buy credit using the app and write them on the bracelet. Perfect. And this is the reward, the beer. I want to show you a meme because it was fun, especially the fun part is that one. But, okay, sorry. How does it work? So, this project, at this festival, I installed this app and I was curious, especially because there was written that it could work offline. So I said, okay, how does it work? This is a very common question that I have for everything that I use, not just for hacking purpose. It's very common for me to ask, okay, but how does it work? And this is a very good starting point to try to understand stuff. This presentation, this project is a sort of love letter to the InfoSec community, because often, at least for me, the best project, the best reverse engineering projects are not ready to try to hack stuff, but just to, hey, let's try to understand how it works. So, low budget, just a laptop and a smartphone are enough, because hacking is more fun if it's for everyone. No root phone. Why no root phone? Well, because I didn't want to invest my personal budget to buy a phone just for to root it, and because rooting an Android phone in 2026 is very frustrating and annoying. It's not so easy like 10 years ago. For good reason, probably. And only local client reversing. I was not interested to investigate the API. I was not interested to find bug in the backend. I was not interested to try to hack a cloud infrastructure. I was interested just to understand if I could hack or find vulnerabilities in the logic of the application. Because if it can work offline, I need to understand why it can work offline. What I used, what I had technically, I had an NFC tag, an NXP 216. It's a very common one. I had the Android application that was a React-based application. And then the direct user experience. That is very important in this case, because I have had the opportunity to use this application in a real environment, in the production environment, so I saw how it works. Tools that I used. So I used the open source tool and solution. One, the most common, is the Android debug bridge, because it helps you to communicate with the connecting the mobile phone to the laptop. You can easily dump data, write data, and so, install application, debug application. I use the Hermes deck. It's a reversing engineering tool for disassembling Hermes bundle. Later we will see what is an Hermes bundle. I use the Android unpinner. This is just a tool to make an APK file, so an Android application, debuggable. Often, production application, and for good reason, has the debug disabled. But if you want to start to reverse Android application, it's recommended to enable or to enforce the debug. Then I use the APK tool to reverse the Android application. This means that APK tool is just a tool to open the APK file. It's sort of a zip file, and you can start to reverse the code, so you have access to the Java class or the Android bundle that can be in JavaScript or, in this case, an Hermes one. Then there is ABC tool, that is another tool for disassembling and assembling Hermes bytecode. The main difference between HB tool and Hermes deck is that with the HB tool you can also reassemble the Hermes bundle, often broken because just one byte change break the bundle, but you can try to reassemble it. It's very helpful if you want just to change Boolean value, because in that case the risk to break the bundle is low. And often the Boolean values are used to manage the logic in an application. And then the NFC tag info and NFC tools, there are two Android applications that you can install for free on your mobile phone to read the data on most common NFC tag. Okay, let's start from the NFC tag. So we have two important, we have two product, we'll say, something, two items. One is the NFC tag, so a physical card, and one is the Android application. I was most interested, honestly, in NFC card to understand how it's work, because often it's quite common to find misconfiguration for this IoT device. So let's see. This is just a sample, but this is what I found by reading the NFC tag. We can see that the lock bytes are on the default value. This means that there is no configuration, and this means that they are boring. Good, because they are not used. This doesn't increase the complexity for us. Then we have the capability counter. This is very common. I mean, it's a very useful feature, or for example, ticket. If you want to create a ticket for public transportation, you want to count the number of usage of the same ticket. For example, if a ticket can have multiple rides or whatever, it can be very helpful. This is a counter. This means that you can increase but not decrease it. Then on the end of the in the last row, we can find other configuration, other lock byte not used, and the authentication. This is interesting because the NFC tag, NXP, and tag 200 something, it's a family of 3 tags, support the authentication. How it's work? Well, it is a symmetric authentication. This means that the password is safely stored in the NXP tag. But when the reader want to authenticate, the reader need to send a command where the password is unclear. So in the ideal world, you can technically intercept the password if you have access to a reader that can authenticate. It's also interesting that the authentication is not required for all the slots, but it's just required from the slot 40, and there is a reason why it's required from this, just for some slot. So what we have here is that, and there is the brute force protection. So the last row is about the brute force protection. This means that after 7 attempts, every authentication will fail. And I have understood this too late, just because I have decided to not read the documentation in time. And so I burned my NXP tag, because I try technically to brute force it. Good lesson. So the lesson here is read the documentation before start to reverse an NFC tag. But let's see now the data about the transaction. So when I was to the festival, I could buy item and I could pay. I could add credits, so token to my bracelet. How they were stored? We're using transaction data in the memory of the chip. You can the application writes the token. Technically, the application writes the transaction, and there was written also the number of token. And so what we have here, that every transaction was 12 bytes. 3 are required for the coins, the number of token. 4 bytes are for the daytime, so when you bought the token or use the token, it depends if. And 5 bytes in the middle are probably a sort of signature. So even if you buy the same, or even if you load the write the same number of token at the same timestamp, with a different timestamp, you have a different signature. And this adds complexity, because I cannot just maybe copy the token, I need to also understand how if I can replicate the signature. And then we can see that there is a similar transaction data also in the read-only memory. Why the read-only memory? Well, the read-only memory is used just by the stand operator. When you buy the beer, for example, they write on your bracelet the rest. So how many tokens you have after that you bought the beer. And sorry, forgot. And one second. Better. Okay. And customer and stand operator seem to use the same transaction format. They have the token, there is a signature, and there is a timestamp. But the operator can write the transaction data in a memory partition, memory slot that the normal customer cannot use. Why? Because the operator slots are protected by a password that I need to authenticate to write in that memory. Okay, so apparently the only difference is that the operator can write in a specific slot where the customer cannot write, but the transaction data, the transaction format is the same. So, cyberquiz. Which kind of attack could we try on this NFC tag? Well, one can be break the transaction signature. If we know how to replicate the signature, we have a timestamp, we have a number of token. If we can sign these two things, we can always write in our in the slot in the customer slot the number of token that we want to have, and this is for free, and we hacked the bracelet for sure. Or at least the logic behind this transaction application. Then we can try to guess the NFC tag password. Why this could be interesting? Well, not because it's allow us to load or write all the token that we want, like breaking the transaction signature, but because we can maybe buy just 10 token, buy a beer, and then just remove the operator transaction data. In this way, we can restore our initial token, and with a small amount of token, we can reorder multiple items multiple times. This is why finding the NFC tag can be interesting, because we can, in this way, delete the operator transaction. And then there is the transaction reply attack. It's the most common. If I cannot guess the NFC tag password, and if I cannot find how the token and timestamp are signed, maybe I can just replicate a transaction data. So I write 10 token on my bracelet, and then I try to replicate this writing process multiple times. Okay. Now, we have 3 different approaches to try to hack the transaction on this mobile application, on this service. And the question is, okay, which kind can work? How I can test them? And here, I started to look more in details to the Android application. So I started to reverse the Android application. Why? Well, because maybe we are lucky. We can find the password directly embedded in the Android application. And so we don't need to understand how it works. We can just use the string. But which kind of Android application I found when I tried to reverse it? Well, I found a Hermes-based Android application. What is Hermes? Hermes is a JavaScript engine with high performance, open source, made by Facebook, and it allows you to create React application that are faster, that are optimized for mobile phone. That makes sense, because you don't want maybe to have if you are working on a mobile application, especially for Android, the ecosystem is so different, is so complex, that optimization is a requirement. So an Hermes bundle is just a precompiled binary that contains optimized bytecode. So it is just JavaScript obfuscated and optimized. But this means that if you try to read, if you try to open an Android index bundle that is an Hermes one, you cannot properly read it. It's a binary file, and you need to start to reverse every bytecode. This adds complexity. Why I have not tried dynamic analysis, for example? Why I decided to go for a static reverse process? Technically I try dynamic analysis, but I failed. Why I failed? Well, there is a lesson also here for me. If you want to try a new technique that you don't know well enough, or if it is the first time that you try, probably starting from a production application or production environment is not a good idea. I mean, for production, I mean that I didn't know the source code of this application. It was written by developers to be used in real life. So it's definitely not the first step. If I can recommend something is, okay, you want to try dynamic analysis on Android application, to reverse an Android application, in this case using Frida Gadget, you can, but start from a very small basic application that you wrote, so you can understand how it works. In this case, for example, for me, it was not just difficult to try to use Frida Gadget on a not rooted phone, but also debugging the reason why it didn't work was not easy, because there were too many different scenarios, too many possibilities why it was not working. So I decided to not invest too much time in this, because, well, it was my free time. I wanted just to have fun when I was reversing Android application. I decided to go with the static analysis, especially because I was hoping to find, honestly, the password, or at least some interesting key, embedded directly in the code. So, let's start. A DB device is a command to find the mobile phone connected to your laptop. Then with Android Unpinner, I listed my packages. So the application installed on my mobile phone. I found my application. I dumped it. Using an APK tool, I disassembled it to extract the bundle, and technically to extract what was inside the application. Initially, I didn't know that was an Airbus bundle. I was sure that was a React application because you can understand it from the user interface. Yeah. Then, after that, I found out that it was an Hermes bundle. I started to disassemble it using ABC tool. In particular, because I was interested to read better, to find the string, try to understand the logic. And also I use ABC the compiler just because it provides a better outcome, in my opinion. It provides a sort of pseudo JavaScript code for the Hermes bundle. It makes sense because technically React-based applications are just an evolution of a JavaScript application. And the pseudocode was better from human perspective it was, in my opinion, easier to understand. So, these are the two tools that I used to reverse the bundle. One provided that was very interesting, the string.json, and so extracting strings, Boolean value, and integer. And this feature is very interesting if there is a ton of client logic. Why? Because if the ABC tool is able to extract this string.json, so you can easily find if there are maybe interesting string, but in particular they are Boolean value. This means that you can change the Boolean value in the string.json and then recompile the entire bundle. In this way, the recompilation should work. And if there is a specific feature, for example, a pro feature that is enabled or disabled by a class logic, you can easily enable it and reassemble the application. Then ABC, the compiler, that provide me just a better output to read the Hermes bytecode that I can, and I mean, in this way I can also use LLM to read the pseudocode, because the Hermes bytecode are, I mean, I haven't properly tested because there were too many lines, but just to be clear, the output, the pseudocode.js file, that is the Hermes reversed, had 2.5 million lines. So the context was too big for an LLM, at least 2 years ago. Okay, now that we have understood how what is an Hermes bundle and how we can decompile it, the next step is, okay, decompile the bundle and start to investigate the code. First attempt was, okay, let's try to break the transaction signature, because this is the best scenario. If I can sign the token, if I can sign any transaction, I have technically free token without the necessity to pay any transaction, because other scenario require that you buy at least the initial token. So this was the function to sign the transaction that I found in the Hermes bundle. This code was rewritten using Cloud Code. What I mean, I launched the ABC, the compiler, against the Hermes bundle. Then I got this giant pseudocode file. I started to read it. I mean, for read, I mean search for specific keywords, for example, password, signature, and so and so. I found the interesting function, and then I used Cloud Code to rewrite them better in languages that I could understand easier. In this case, JavaScript, just because, yes, but in general I prefer Python, for example. But the functions were quite basic in my opinion. So this is the function to calculate the signature. We can see that it's required the number of token, it's required the timestamp, so when you bought the token, but it's required also a secret that is dynamically injected in the function. Then it concatenate all the values, so the token, the timestamp, the secret. It calculates an hash and return it. So now we know how the 5 bytes work for the signature. This is how the application sign the transaction data, but we don't have the secret because it is dynamically injected, and apparently it was not in the Hermes code or in the application code base, or I was not able to find it. This means that we cannot easily break the signature. In addition, you need to think that all this reversing project was made at home after the festival, and this means that I could not test all my theories. So if the idea was, oh, maybe I can intercept the traffic, I cannot, because I was not to the festival, so I cannot really test it. Okay, so this approach could not work because we don't have the secret. Let's try to guess the NFC tag password. I mean, let's try to check if it is embedded in the code, in the application, and it wasn't. Or I was not able to find it, but I'm quite sure that it wasn't. So how the application generate a password for the NFC tag? Well, it is interesting because there is a unique formula, a unique function for all the bracelets, but all the bracelets have a different password. Why? Because it is generated using the UID that is unique for every bracelet. It is provided by NXP directly. And and there is a secret again. So these functions work like the previous one. We have the UID, a data that we know, but then there is a secret that is dynamically injected in the function to calculate the NFC, to generate and then use the NFC password. This means that also this time I cannot use, I cannot find or guess the NFC, the password. And, okay. So what is the remaining attempt? It is the transaction reply attack. Well, this is quite basic approach in general. So you have an NFC tag and you just try to replicate the data. So copy the data that you have in other slot and see if the reader consider the new data valid data. How you can prevent this kind of attack? Well, it depends. You can add logic where you want. You can add check in the backend, in the reader. In general, it's the reader that should check if the data are replicated or not, or valid or not. It's the NFC bracelet is a very static object, and it cannot do calculation or any sort of operation, advanced operation or check. Sorry. So let's try to understand how the bracelet, how the application run checks on the bracelet data to prevent replay attack. So this is a big function that I tried to compress. We can see that there are two checks. One is for the operator slot, and one is for the user slot. The operator slot were in read-only. We know this. They are protected by the password. We cannot write the operator's slot. We can just write the user slot, and in this kind of slot, we can try the replication attack. So let's try to understand this function. It just say that if the application read all the transactions in the user slot, check if there are duplicated timestamp. If there are duplicated timestamp, the application just skip that transaction. So just this block a replay attack in our case. Why? Because if we want to replay, we want to replicate a transaction data, we need to copy the token, the signature for sure, and the timestamp. Just copying this means that our copied data has the same timestamp. So one of the two transactions will be ignored by the application. And then there is also another check. A check on the timestamp of the user slots and operator slots. Why? Well, this is the logic of the application. This is where, honestly, I started to think more. So, if you buy 10 credits and you write on the bracelet and you go then to buy an item, the vendor need to write the rest on your bracelet. That will be lower than your initial amount of credit, and the timestamp will be more recent. But after that, if you buy additional token, the application, and you write on the bracelet, the application need to sum the operator slot to the new added token. And this is why there is a check on the operator timestamp. So what was the check? Was this. If ignore all the transaction data that are older than the operator timestamp. If the transaction data are equal, or the timestamp of the user slot are equal, or higher than the operator's timestamp, consider them and sum to the total credit. And this is how the application calculates the amount of token that the user have. So by summing the operator slot to the user slot that are more recent than the operator's slot. Okay, but why just minor and non-minor or equal? And let's start with math. So what we have here, we have a problem. I mean, this means that the replication attack is possible, but not copying the credit by the slot by the user, but by copying the slot by the operator. What happened there is that, okay, but what happens if I copy a transaction data written by the operator? For sure, it will pass this check and also this. So I cannot do a proper replication attack from the transaction data of the user, try to replicate them, but I can do a replication attack copying the operator transaction data from their slot to my own one, because I can read them. The slot were in read-only mode, so the password was necessary to write or delete the transaction data, but I could always read them, and that makes sense because the application need to calculate the amount of credit that I had. So let's start to do some math. We have an initial amount of token. We know that an item costs Z, and we know that X need to be higher than Z. And what I tried to understand it was, okay, I can optimize my replication attack using math, and the answer was yes, because the idea is that if you want to buy the minimum number of token to, I don't know, buy free a beer for the entire festival, you just need to understand this formula that was, okay, you just need to buy the number of token of one beer, multiplicated per 2, and adding what just token to that. If you have this, you have a divergent condition, and this means that for the entire festival, you can drink for free. So the magic formula in this specific application logic was, due to that minor thing that was not minor equal, was, okay, I can do a replication attack on the operator slot, and now I need to find a condition to minimize the amount of token. And the divergent condition is the reason why you can drink for free just paying 2 beer plus €1 to a festival. Mitigation. How you can mitigate it? Well, there are a different way. One of the conditions about this project was ignore the backend. If you add control in the backend, you can check everything. But if you want to mitigate this in the app, there are, again, multiple ways. My recommendation was this one, add an equal and you solve the problem, but also use different signature between operator and user slot can solve the problem. So in this case was just a logical issue, just an equal forgotten that allowed me to drink for free to a festival. And thank you, that was my homemade project. I hope you have fun and I hope you like to drink beer too. Any question?
Any question? No? Uh-huh.
Sure question. Yeah.
First off, great talk. Very, very fun, I would say. Unfortunately, my question is not so technical. I'm wondering what festival you went to that sort of spawned this. Which festival did you go to that sort of, you have these...
I cannot disclose that, I'm sorry.
I
cannot disclose.
Too bad.
Relatable? Yeah.
But good question.
Yeah, thank you for a great talk. I would have question. This was about payment, and would something of this apply also to access badges based on the NFC?
Can you repeat the question, sorry?
If this similar technique or the analysis or the process or the vulnerability can be found in the access badges using the NFC?
Well, potentially yes, but the NFC tag in this case was not vulnerable by design. The NFC tag was safe. I tried to understand if I could try to exploit just the hardware, but then there are no well-known vulnerabilities for the NXP and tag, for example, family. The reason why I was able to hack transaction was a logical error in the application, in the product itself, not in the NFC tag. So my answer is yes, but not because then the NFC is vulnerable, but maybe because the logic in the reader or in the backend or in the application is vulnerable. So you can try to replicate, but it's custom every time. Thank you.
Thank you.